Okay, so an ordered pair is called an ordered pair because the numbers have to occur in a specific order. X occurs first and then Y. There is a Z if you're going to graph in 3 dimensions, but that is not for a while. You'll do that in Algebra 2. So X is called the independent variable. And so if you are dealing with a real life situation, you can choose any variable for the X, and then you plug it into the equation, and you can find the Y variable. And that value is determined by X. So you have X, which is the independent variable, and Y depends on X. And we're going to talk about how to determine which is the independent, or the X, and the dependent variable in a little bit. So one type of problem that you'll see on occasion is they'll give you an equation that have 2 different variables in it. So for example, you have an X and a Y in the equation. They'll give you an ordered pair. So here we have an ordered pair, and again, it's called an ordered pair because the variables come in a specific order, X and then Y. And then they ask you to find the missing coordinate. So you'll notice that Y is missing, but they do give you the X. So to find the missing variable Y, you just plug in 2 for X. And what do we get, everybody? Okay. 3. So when we plug in the missing coordinate, we get 2, 3. Any questions?
So it's just solving?
It is evaluating. So if we plug in and don't have to like add anything to both sides or divide anything by both sides, we're just, figuring out what 2 times 2 minus 1 is, we'll call that evaluating.
Oh, okay.
Other questions?
Can you repeat that?
Sure.
Right.
So how does
Yes. So the 2 is because they gave you an ordered pair and they gave you the first number. And the first number is always the X value. They could give you the second number. If they give you the second number, you can plug it in where you see the Y. So this is called our rectangular coordinate system. It's called rectangular because all of the axes meet at right angles. So you can have everything like put on like a sphere, in which case it's no longer a rectangular coordinate system, but we're putting it on a flat surface. So it's a rectangular coordinate system. We have the x-axis, which is generally always horizontal. We have the y-axis, which is generally always listed as vertical. And when we cross the 2, where they intersect, we call the origin. It's also called the origin because when you graph points, that's where you start. So that's where you originate. When you go to the right on the x-axis, the numbers are positive and they just get bigger infinitely. And when you go to the left, they are negative, just like a regular number line. And then on the y-axis, when you go up, they're positive, which is pretty intuitive, because up, positive, and down is negative. Now, something that is not as intuitive is the fact that when you put the number lines vertically and horizontally with each other and create the x and y axes, you have now cut the coordinate plane up into 4 different, what are called quadrants. Quadrants because there are 4 of them. And when you name the quadrants, they are named with Roman numerals. The very first one, which is in the upper right-hand corner, is called quadrant 1. So here, that one is quadrant 1. And then you name the quadrants going counterclockwise. So quadrant 1, 2, 3, and 4. So those are our 4 quadrants. That is always what they are named. This will also be the order that we go around when you get to trigonometry. So it's, yeah, I know, it's a math you're going to do later on, but most of the rotations you're going to do will always be in this direction, which is counterclockwise. And I once asked a math professor, why is always everything counterclockwise? And his answer was, well, the clocks are wrong. So I don't know why he said that, but that's what he said. So counterclockwise rotation from quadrant 1 to quadrant 4. Notice that if you are in quadrant 1, all of the points have positive x and y values. If you are in quadrant 2, the x values are negative because you're on the negative side of the x values, and the y values are positive. If you're in quadrant 3, do you guys see how everything's negative? Negative x and negative y. And then if you're in quadrant 4, you have positive x values and negative y values. So your x's and y's change positives and negatives depending on the quadrant you are in. So that is our coordinate plane. It's also called the Cartesian plane. It is called that because Descartes is the mathematician who formalized it. Questions? Okay, so with this particular problem, I'd like 4 volunteers to come up and graph the 4 points. Okay, we do have stuff to do also on the next slide, so if I don't call on you, I will get to you later. So I'm just going to go in order. We will do A, B, C, D, and then I'll save the rest of you for another slide. Please label the point with either the letter or the ordered pair. And you guys in the audience can see if you agree with what they do. You can go 2 at a time, so if you are at a different quadrant,
Oh.
Joking at a time.
No, we will not have 2 go at a time. We will do it single file in orderly fashion.
because you go 4 in that direction.
Was I supposed to
And
do
negative
that?
2 and y.
No, I was supposed to do it.
Oh, okay, my bad. My bad. Here you go, DJ.
All right. Put a thumbs up if you agree with A. Okay, how about B? C? No, not B.
Oh, sorry.
And D. Okay. Yes. Are any of these not in a quadrant? They're all in a quadrant. Okay, good job. All right. So now you're going to give the coordinates and state the location. Now, the locations are going to be, for example, quadrant 1, quadrant 2, 3, or 4, or it can be the x-axis, the y-axis, or the origin. Okay, so Brendan, you can do A, B, C, and D, Damian? You can do Q1, Q2, Q3, Q4.
Brandon, I said you put O. I was like,
No.
no. I thought you put an O. I was like, oh. Good one.
Let's
She
go
can
there.
give it to me. Oh, Davion, different. One of a kind.
Okay, let's take a look.
We are above average students. We get everything right.
All right. What do you guys think of his change?
That's very good.
Great.
Good
Oh, yeah.
I'll give you
That's right. I thought that's okay.
So, do we have a thumbs up or down for A?
Oh, wait. Wait. No, it's three. It's three.
It is? Oh, I don't know my numbers.
I got it wrong too.
Yeah, count.
Oh, that's yours?
Okay. I guess, are we good now for Q1?
Yes.
Okay. How about B, thumbs up or down?
Wait, B or C?
B,
Yeah.
I said negative 5 and
Yeah.
negative 5, 2. How about C? D?
Yeah.
Okay, so I would say the biggest problem people get wrong is Avion's problem. One thing they get wrong is they reverse the coordinates, so good catch. The other thing they get wrong is they name this as being in a quadrant, okay? It is not on a quadrant, it is on an axis, okay? So D is on the x-axis, and remember, when you are graphing a point, you start at the origin. You would go 1, 2, 3, 4 in the x direction, and then 0 in the y. That's why it is 4 to 0. Questions on that? So the dependent and independent variable is something that is difficult for people of all ages, really. It's a tricky concept. It's covered in the sciences as well as math. And I know this sounds a little redundant, but this is how I think of independent and dependent variable. So the dependent variable depends on the independent variable. So when I'm testing if something is the dependent variable, I use that sentence and see if it makes sense. So, for example, the number of articles of clothing one wears depends on the outside temperature. So that means this is the dependent variable. So if it's cold outside, I'm going to wear more clothes. If it's hot outside, I'm going to wear, no more winter coat, no more, scarf. And this is the independent variable. If this were reversed, okay, literally what it would mean is if you put more clothes on, it would get colder outside. Do you see how crazy that sounds? If the temperature outside depended on how many clothes you wore, you could control the weather. Okay, so that is not the case. Next, the amount of gas consumed in a car depends on the miles driven. Okay, so the more miles you drive, the more gas you consume. Right? So this then would be the dependent variable. And this is independent. Another way I like to think of it is independent are things that kind of this kind of varies, but like the amount of gas consumed depends on how many miles you drive. So you can choose how many miles you drive, but you can't choose how much gas is consumed. So how much gas is consumed depends on how many miles you drive. So that is the dependent variable. Okay. Questions? So we're gonna circle the independent variable and underline the dependent variable. So the more an athlete practices, the better her performance. So which is the dependent variable and which is the independent variable? Not me. So does the practices depend on her performance?
Oh. Yeah.
Or does her performance depend on her practices? So we can write it out. Her performance depends on how much she practices, or the practices depends on your performance. I think it makes more sense now. What's that? So how well you practice depends on how you did in your performances, or are your performances affected by how much you practice?
Can it be both?
You know, it kind of is, but Isabel, do you have something? Yes. So the more you practice, the better you'll perform.
But isn't it?
Right.
You get better.
Yeah.
Right,
It's saying
right.
the performance depends on the practice. Okay.
Right. So the performance depends on the practice. So what's the dependent variable? Performance, yeah. So you're supposed to underline the dependent variable. This is dependent. And this is independent. Okay, so the amount of sunlight a plant gets affects its growth. Charlie?
I think growth is the dependent.
Okay. So you're saying growth depends on how much sunlight. Yeah? Yeah. So growth is the dependent. Sunlight is independent. Yes. So if sunlight depended on growth, that would mean, oh, hey, my plant is 3 inches high, it just got sunny outside. Do you see how weird that would be? But this means, hey, my plant got more sun today, therefore it grew more. Okay. So the growth depends on the sunlight. The more sun, the more it grows. Questions on that? So the way linear graphing relates to real life in one way is through something called a scatter plot. So a scatter plot is a graph made by plotting ordered pairs, and the ordered pairs is 2 sets of data. So we could graph the following. We could graph your weight and your height. We could graph your test scores and your shoe size. We could graph your hair length and your nose length. Okay? Any 2 pieces of information about one thing can be graphed. One thing on the x-axis and one thing on the y-axis, and we can see if there's a relationship between the 2. All right? A lot of those things were pretty random, but some things might not be, like weight and height, okay? Especially of little kids. You know, when you're born, maybe you're 21 inches long and you weigh 8 pounds, and now you might be, let's say, 60 inches long and weigh 100 pounds, okay? You're gonna have a correlation. So, below is a table that shows a student's test scores and amount of time spent studying. So we have hours spent studying and the score on the test.
Wow.
This could be like for the
That's it.
SAT.
Oh.
Okay, it doesn't have to be for a math quiz. What would be the independent variable? Brendan?
The score.
Or,
Oh, percentage. Or, oh, no, hours, because it's, yeah.
yeah, so the reason it's hours, and hours independent is like the thing you can control.
Right.
You can control the amount of hours you study. But the score you get depends on how many hours you study. Ideally, you have some control over that. Okay? And generally, independent comes first and dependent comes second. It wouldn't make sense otherwise because of like, you don't get your score until after you've studied. So the score has to depend on the amount of hours you studied, just for a, space-time continuum reasoning. Yes?
I thought that trick, like last year, Mr. Grossman, when we were doing this, independent, he said like, I'm doing it, like, you can go, like, for hours, it depends on how you, like, I'm doing this many hours, like,
So like you have control
Yeah.
over it?
Yeah.
Okay.
or is changeable.
Changeable? Okay, that's a good trick. Yeah, thank you.
So the dependent comes first, you said? Most of the time?
Independent comes
Oh,
first.
So independent is one that can change, but the dependent can't?
Yes. Independent is the one generally you have control over.
Oh, no.
So you control how many hours you study. You decide that. You also, to some degree, control your school, but not to the degree you control your hours of study. That you definitely have control. Now, all of these in that chart can create an ordered pair. And it's really nice when in the charts, the X comes first and then the Y, because then we can make ordered pairs out of them. So these are the X values, these are the Y values, and then you can just make ordered pairs, right? And with those ordered pairs, we can create a graph. So that's what we're going to do. Let's do this on a split screen view so we can see them side by side. Now, when we create our graphs, we know we're going to put our hours on our x-axis because that's our independent variable. What do you think we should number by? Not me? 5 is good. Where should we start?
No.
0? Yeah, why not? We could start. Yeah.
Starting, honey.
And we can go on by 5s. I'm going to skip a line every other. The reason being that it is very important, ladies and gentlemen, to spread out your data. You don't want to smush it because it's easier to see relationships if your data is spread. Could I have spread it more? Perhaps. Now when we go to score, the beauty with scatter plots is you don't have to number the same, you don't have to start at the same point. You can do whatever makes sense for the data. So with the test scores, does it make sense to start at 0? No, his minimum is nowhere near 0. But what you do have to do is add what is called a break in the graph. To show the audience, I am not starting at 0, I'm going to jump. So it's almost like I rip off a part of the axis and I'm going to go straight to, in this case, I'm just going to start at 55 because that's my lowest value. And my highest value is 89. What you do not want to do is just write these numbers down, okay? Because this is a number line and you have to go up by a consistent amount. So 55, 65, 75, 85, this is not great. Do you see how crowded this is? I'm gonna even more so. Maybe I started at 50 and then go 1, 2, 3, 4, 60, 1, 2, 3, 4, 70, 1, 2, 3, 4, 80. This is beautiful. 1, 2, 3, 4. Oh, look at that, okay? The more spread out it is, the happier the graph is. Because eventually, you guys will be writing equations based on these scatter plots. And it's going to be much easier for you to write an equation if the data is spread out. So now, I think it's Ashley, Isaac, Denise, and Talisa. I want you guys each to graph one of the ordered pairs.
Okay.
Did I skip you, did you?
What?
Did I skip you?
There's like a lot of things somewhere.
Yeah.
For some reason.
Did TJ make a bad choice?
No, I think it's like that's all.
And you sure it's like you
By 2? I'll just put the... So each of those represent a person,
Oh,
okay? One person studied 5 hours and got a 55.
3 hours just to get an 89.
Yeah, but if it's a standardized test, that's really high.
Oh, but I'm like, for regular.
We just...
Those are perfect. Who did that?
You're the only one that you did.
Oh, okay. I think more things just possible. Please hold
Okay, stop.
So someone's moving in. Oh.
Wrong. Just chill, don't touch.
I don't know.
No. I'm gonna do it down one.
You're welcome.